Before break, everything we could imagine about angles we did. Inside, outside, floater, central, inscribed. We did them all the different types of angles. So we're done. I can't show you any other different types of angles. We're done with that. Now what I want to go is, how do I find the lengths of these chords, these secants, and these tangents? All right, how do I find the actual lengths of them? And yes, we are going to start this off the right way with a proof. Welcome back. Here we go. Proof to A, whoa, times BE equals CE times DE. Dig deep. Where have we seen that proof statement before? What unit have we done this already? Oh, well, we've done a lot of triangles. We've done probably 3 units of triangles. Similar triangles, yes. This is a similar triangle proof. So before we get into anything here, let's prove the triangle similar. Main method. Angle, angle. So can you get me 2 pairs of angles right now that are congruent? Here we go. Let's start it. Fire it up. 19. Start us off right. Yeah. Oh, yeah. We know why. Great. Yep. CEB. Congruent to angle AED. Verts or vertical angles are congruent. Yep. Good old days. Great. Okay. Well, took the easy one away now. Now you got to find me another pair. And why? This is coming from this unit. 17. Let's dig deep. Come on, you got it. Yep. Or he could have gave me C or A based on the same reason, which is going to be, hold on, calm down. Angle B congruent to angle D. What do you got for me? Ah! Thank you. Beautiful. Inscribed angles drawn to the same arc are congruent. Nice job. Fresh cut, Teddy. Homegrown, professional. It wasn't sure wasn't one of the choices, but did you do it at home or did you go get it done? Professional? Are you happy with it? Yeah? Did you get a say in how it was cut? Okay. What was the conversation? What do you tell them to do on your hair? Okay. All right. All right. Thank you. All right. Moving on. Sorry, I just wasted a good minute and a half of your lives, everybody. All right. Now I have 2 pairs of angles already done. Now you can tell me the triangles are similar. So I'll go triangle CBE. Similar to, if I go CBE, I got to go ADE. Check your work right now. How many people are embarrassment right now? Wrote the congruent sign. Yep. By angle, angle. Okay, I don't know if you remember the next step, but it's not our proof statement. After the triangles are similar, what do I know about the sides? They're in the same ratio, so you guys need to set up a correct proportion right now that will lead me to this proof statement. So yes, I can put AE really anywhere I want, but now when you put BE, where's BE have to go? Correct, so I'm going to end up cross-multiplying here. So BE right here, because you're going to end up cross-multiplying, and then CE and DE can go in the remaining 2 spots. And then do we remember this reason, why the sides are in proportion? Corresponding sides in similar triangles are proportional. CSSTP. CSSTP. Then that brought us to our proof statement. because when I multiply AE times BE, that'll be the same as CE times DE. Anybody going to dig deep for this one? I won't call anybody, but product, because I multiplied, yep, product of the means equals product of the extremes, yep. Good to get refreshed here with a proof. All right, but why? Why is I just select this one to make your lives miserable as you came back? Absolutely not. Let's try to translate this over to circles. What are CD and AB in that circle? They're chords. Everyone agree? They're chords, and they're intersecting chords at E. We just proved that if you take that part of chord AB, we call it AE, and multiply it with BE, what's it equal to? The other two parts of the other chord. That's what I do. That's the theorem for today. Is if you have two intersecting chords, and don't write this on yours, I got a ton of examples coming up, but if I put 3 and 4, 6, and X, you'll be able to find X. What theorem did we just prove? 3 times 4 is going to be the same, equal to 6 times X, and now I have an equation I can solve. Okay, I'm not going to bother. There's not really a good theorem with words to put in, so I'm not going to put one in, but we're going to dive right into it. Number one. Everybody see the two chords that are intersecting? Based off the proof, what did we just prove? Set up an equation using what we just proved. Here you go, 25, you're up. What are the two parts of one chord? 8, so 8 times 2.5 is equal to, I go to the other chord now, and its two parts, which is 6. What else do I have here? X times 2. Everyone see how this theorem works? Only for chords. Only for chords. Oh boy, what do I have here? Something equal to 2x. 24? 20. Got me there. So x equals 10. Any question on this theorem before we raise the level here now? On number 2. Okay. Let me ask you this. Do you see two chords in this diagram? You see two chords. All right, most of you probably see this one, the one that's made up of 8 and 10. And remember what else is considered a chord? The diameter. All right, the diameter. All right, well, I think it's pretty easy for most of us to set up the first part, which is 8 times 10. All right, now we got to slow down. Now I need the other two parts from the diameter. Whew. Okay. Well, I know one part's X because I labeled it. What about, here you go, take a look. What about this little part here? I'll do in red because that's what I'm going to have to multiply it with. How can I figure out what that part's going to be? How can you express to me what the length of this other part's going to be? I got 8 times 10 equals X times, oh boy. But I did give you this little bad boy right here. What's this? Radius. So that must mean this diameter is what? 24 units. That part's X. What can I call the other part then? Oh, 1. 24 minus X. Everyone see where that's coming from? Radius is 12. Diameter's got to be 24. If you're going to tell me one part of it's X, the other part's got to be 24 minus X. All right, and yes, I'm sure some of you may know what's coming up, but let's get going. I got 80 equals 24x minus x squared. Oh boy. I'll turn it over to you right now here, Honors Kids. 22, your next move now. I got 80 equals 24 minus x squared. Got to solve for x. Yes, and I know the easy way would be to move the 80 over, but I'm not a big fan of that bad boy right there. All right, so I'm going to move the 24x and the x squared over here. So x squared minus 24x plus 80. All right, here you go. I don't have time to break out the old quad formula. What are your two numbers going to do right now? These two magic numbers. Multiply to 80 and add to negative 24. Go ahead, play around. Play around a little bit. Got to multiply to 80, add to negative 24. Dig deep, dig deep. Four. Did you find those numbers, Emma? Yep. Got it. So I end up with x to be 20 and also 4. Usually when we come to this point, we reject one of them. Because when I plug it in, it gives me a negative length. But I don't get a negative length here, do I? Still going to reject one, though. Can't keep both. There's a reason. Mathematically, I cannot keep both. I know it doesn't give me a negative length, but there's another reason why I need to reject one of them. And not because it looks like it. Something doesn't make sense geometrically here. What's the radius length? 12. So how can this little piece, which is shorter than the radius, be 20? Right? Everyone agree? So 20's gone. Got to be 4. I'm listening, Teddy. Then I would accept both. I don't have a reason to reject one, but you see why I have to reject 20 here. Okay, because it can't be bigger than the radius. But you're right, I would accept both then, Teddy. If that it came down to that one. All right, good deal. All right, find the length of chord CD, the entire chord, if it is 3 centimeters from the center. All right, plop the 3 down, 3 centimeters from the center is chord CD. And the radius measures 5. Okay. So can I put something here? A 2 spot? Is there anything else I can add to my diagram? What about this distance from here to B? 5, yep. And any other markings I can put on here? Why are these two going to be congruent? Woo. Why are these congruent? Better dig deep with the theorem for me. Diameter, perpendicular chord does what to the chord? Bisects it. Everyone see two chords. There's a couple. I realize there's a couple different ways to do this one. All right, but does everyone see two chords up here? Chord CD and chord AB, which is also diameter. So fill it in for me here. Give me 2 parts multiplied equal to 2 parts from the other chord multiplied. Who's up here? 28. Let's get it rocking and rolling. Excuse me? You had one job. Part times part. What's one? So if you're going to go AB right now, what's one part of it? Okay, calm it down. You're just getting out of control right now. Hey, Ray, here's your chord AB, right, Liz? 8 times 2. I got this part up here, 2 times the rest of it, 8. So 2 times 8. And then what can I put for chord CD? 16. What can I put for chord CD? They're both the same. Yep. And there you go. X and X. 16 equals X squared. X equals 4. Better read the darn problem, though. Congratulations, you found X. You're not a winner. I'm looking for CD, not X. X is just part of it. 29, any suggestion? Looking for the entire length of the chord, Dan. CD. There you go. Thank you. All good. You're on your own for the next one. You're on your own. Got numbers and ratios. Got to draw your own diagram. Beautiful. All right, let me turn it over to you here. 25. What'd you put on RE and ES? RE to ES is 3 to 4. So what'd you put on RE? Not just 3, but 3x. And how about ES? 4x. Now I have two chords intersecting, which means their parts are equal. What equation did you set up to solve? 16? Whoa, easy, superstar. Just the equation, please. So 3x times. All right, yep. Didn't know we had an algebra superstar in the house. Sorry. 29, here we go. Let's go. Come on, Dan. Okay. What'd you do from there, Dan? I'm nervous. Darn right you did. And you got x squared equal to 4, and then you got x equal to 2. Hopefully we didn't stop there. You plugged it back in. RE would be 6, and ES looks to be about 8. And if you want to do a quick check, 16 times 3, 48. 6 times 8, they should be equal to each other. Whew. Questions? Everyone have a good break. Good to hear. All right, moving on. Just had to throw that in there. Seemed like I cared. Hey, another theorem. Here we go. Another one just added on to this entire unit. If you have two chords that are parallel, the arcs in between are congruent. Let me say that again. If you have two chords that are parallel, the arcs in between them will be congruent. Okay, nice little theorem to remember. All right, the chords are parallel, the arcs in between are congruent. So I'm going to do the first one here with you and then let you go on to the next. What do we got? 2 after that? All right, so I got AB and CD are parallel. Before I start with the actual values, what arcs are congruent up here? 4, what arcs are congruent up here, Emma, if those chords are parallel? So AC and BD are congruent. I've given you that AB is 80 degrees. What about CA? Make sure you realize that COD is a diameter. Oh, 9. Couple questions for you. What type of arc is CABD here? Semicircle, how many degrees? So I know something equals to 180. I got 80 plus, these two arcs I already know are the same, so I can say 2x. One way to go about it. 100 equal to 2x. X equals 50. What are they doing to you, Dan? Why are they getting the case today? I don't know either. All right. Anything you would like to respond back with? You're going to take the high road? Good man. Good. I respect that. Next two. Next two, please. Next two. $360 degrees in a circle, 180 in a semi. I'll probably give them to you today. Okay? Wouldn't be that harsh on you. Okay, can we a little help with the second one? Gonna need a little help from somebody with the second one. 16. We're 16. Oh, hi Emma. How are you? You just want to throw the answer out, or never mind. No, never mind. Never mind. Oh, nice. All right, let's start there. Those are the first two arcs. Good. And then how'd you find CD then? Yep, I got you. All those arcs add up to 360, and I know the BC and AD were congruent because the chords were parallel. What'd you have for the final arc? $140. Can I get a confirmation there? $140. And then this final. Ooh, how about this one? I don't know if anybody got nervous with this one. Ooh, and I had congruent. Look at that. Ooh, we're going to need a stud here. 13. 13? Okay, anyway. If those two chords are parallel, what two arcs are congruent? Okay, so I got 30 and 30. I got a 50 here, and I'm looking for DE here. What's your plan? 13th one? That's my plan? Yeah. Oh, okay. So DE is congruent to CE. You better have a theorem for me. You are correct. Why are those arcs congruent? Congruent arcs are across congruent angles. Chords. Congruent. Congruent chords have congruent arcs. Yes, congruent chords have congruent arcs. All right. Now that we're past that hill, how do you find x then?
I added 50 plus 30 plus 30. Yeah.
And set it equal to what? 360. And then what was our final arc measure here? 125. We all good? Can I get a confirmation there? Okay. Go ahead, start it up.